Okay, this is the 2004 map, and if we look at the outcrop patterns, it appears it's quite a complex map. But let's break it down into several different sections to make it easier to interpret. Over on the left hand side we have a layer of rock, which is rock unit A, which has a low dip, and it's the lowest amount of dip that we've got anywhere on the map. It's only 10 degrees. It's cutting across the fault F2, these layers down here which are tilted 35 degrees towards the northwest, as well as the steeply inclined rocks above F2. That would suggest that this layer is an unconformity. So let's put the unconformity symbol on. Okay, so now we've got F2. Now F2 is a very wiggly line, which will suggest that it's a very low angle fault. The layers of rock below the fault have got a low angle, whereas the layers above the fault have got a very high angle. Below F2 there is also a pluton, and you can see the pluton starting here and it finishes over there, and this pluton cuts across these layers which are dipping 35 degrees to the northwest. So above F2 there appears to be a series of folds, and this can be identified by the fact that rock unit S is vertical here, it's repeated again at 45 degrees, and it's vertical again over there. So one fold APT will be in here, and it appears to be an antiform. It's got vertical and tilted off to the east here, and then there's another one here 45 degrees that way, vertical here, which will suggest that it's a synform. Okay, now we're going to transfer the information to our scrap bit of paper and work out the order in which we're going to draw our cross section. As always, X and Y should be marked in so that we can line things up on a cross section. Notice F2, put long lines on here, same for the unconformity. Layer A above it that's tilted 10 degrees towards X. Put a small boundary in here which is rock unit B on this side, and I've got rock unit D there, and then I've got these layers which are above F2 which are folded. So R, S, T, S, R, S and T, and we'll put guides for where we think the fault APTs are, the fold axes, the cross section in orange below. So we've got most of the information on. One thing I need to add on now is dip direction. So between these two fold axes, they dip in 45 degrees here. This is vertical, long and short of the cross, long and short over here. Now we need to work out which layer we're going to draw in first. Well, the youngest layer is definitely A, it cuts across everything. Okay, then we can see that F2 and the layers above F2 all cut across these lower layers here. Now I think what I'll do for this map is I'll sort this layer above F2 up first, and then I'll do the layers below. So I'm going to mark in F2, I'm going to do layers above F2 and then the layers below F2. Here's the cross section. Let's start off by putting in rock unit A, which will line up X and Y. Outcrops here. It's got a 10-degree dip. very low angle. Now we know it extends over some section, but we don't know how much, so I'm just going to move it out as much as possible, but not too far over here. And this is rock unit A there. That's our first layer put in. Now we need to do F2. In the exam paper we're just told that F2 dips towards the east, but if we mark on where we find F2 on the cross section, it appears that we find it there at the surface and here at the surface there. We've been told F2 is below a depth at this point here. So what we can do for this is join those 2 points up with those. I'm looking for those I've done it correctly because it lines up very neatly. And I know it gets stopped by A because it's below the unconformity. So we've marked in F2. And that fits with the idea it's a very wiggly line on the map, so it must be low angle. Now what I decided was that I'm going to sort out the layers above F2 and then do the layers below F2 afterwards. So I'm going to fill in this area here. So I know from looking at the map that I'm supposed to have 2 folds, an antiform and a synform. So I need to mark that on and demonstrate it. So there's my first change. There's another one there. Okay, I'm going to put the letters on so I know which layer is which, just below the surface. And what I'm going to do is work from the left towards the right. So these 2 boundaries are vertical, and these 2 boundaries are vertical. These ones in the middle are all 45 degrees. So put the vertical line in. Okay, now I've got starting into S again. So looking at this, it's 45-degree dip. Now, remember, I've got the RS boundary here and RS boundary there, so those 2 layers can join up. And I've started to put in my antiform. This one again is 45-degree dip. And S again here is vertical, so draw a vertical line. And so is this one here. Now S should have the same true thickness across the map, and I think we've managed to achieve this. Everything under here is T. Got S, so I can put my fold axis in. Synform should be at the same angle because I've got the same sort of dip maps on either side. So let me do that. Put my symbol in for that section there. Alright, so all I need to do now is work out what's going on below F2. Now, as I mentioned before, on this section of the map I have a Pluton, and the Pluton is cutting across these 2 layers here. So I need to put 3 lines in. Now this one here, luckily for us, have been drawn on for us. That's what it says in the instructions up there. So this layer on this side is rock unit D, and this one here is rock unit B on there. So all I need to do is put this Pluton on. And if we use a technique we've used before, treat this F2 like a unconformity, and you can predict where you think that boundary would be. So I think it'll be somewhere around about here. I mark that on to my scrap bit of paper. So this is rock unit H on this side. Transfer that information onto here. Remember, it's not at the surface, it hits the base of F2. I think it's going to hit the base there. Because it's a Pluton tilted towards X, I'm going to draw a steep line on like this. Rock unit H there. So all we need to do now is we need to mark on the fault arrows. Now we've got very steeply inclined beds above F2 and very, well, less steep beds underneath F2. That would suggest that this layer has been dragged up because it's been more intensely, it's been metamorphosed as well. So, and the fact that it's a low angle fault would suggest it's a thrust. So there are my fault